Hi everybody, we're going to analyze the graph of a rational function and we're going to follow these steps and graph. This step here, using a graphing utility, I'll leave that up to you to do. And also, instead of me doing this step, I'm just going to show you how to do it if you didn't have one. So I'm going to set up intervals for this. Alright, and also the symmetry, you should know how to set up, replace this. This is even and odd or neither functions. And I do have a video on that, so you should kind of already know this before you get started. Okay, so the function we're going to do first, our rational function, is x plus 1 over x times x plus 4. Okay? The first thing you need to know, and I'm going to go put it on this next slide, we have Rx equals x plus 1 over x times x plus 4. So the numerator is my p to the x, and my denominator is q to the x. So we can set those there. And I just need you to know the degree. So the degree in my numerator, I'm going to call this like p to the x to the n. So I'm going to let n be my numerator degree is 1. However, degree in the denominator is 2, because if I distribute here, I get x squared plus 4x. That's going to help us with our horizontal asymptote. Now we're going to do step 1. Step 1 is find the domain. That means you set the denominator to 0. So we get x times x plus 4. We know the denominator, we can't divide by 0. I do it this way. So x can't be 0, and x also cannot be x plus 4. I mean, it's just that x plus 4 cannot be 0, so x cannot be negative 4. So my domain is all real numbers, however, or such that x cannot be negative 4 and x cannot be 0. That's step 1, the domain. Step 2 is the intercepts. So we have r to the x equals x plus 1 over x times x over x plus 4, like that. All right, the x-intercept is when you let y be 0. So basically, when you let y be 0, this is your y. What happens when you cross multiply, the numerator goes away. So basically, we're just setting p to the x equals 0. And when you do that, p to the, well, when you set 0 equals x plus 1, we get x equals negative 1. So this is going to be negative 1, and when you plug it back into your original equation, you're going to get 0 in the numerator, and so 0 over anything is just 0. So that's your x-intercept, or your roots. And then we're going to find the y-intercept. The y-intercept is you just let x be 0. So if we plug in y equals, everywhere there's an x, I'm going to put 0. I'm going to go ahead and use this one. We get 0 plus 0. We can't do, we get 1 over 0. That's undefined, so there is no y-intercept. Okay, this was step 2. Next step, is step 3, and that's going to test for symmetry. Okay, so we're going to check for r of negative x. So everywhere there's an x, I'm going to put negative x. So we get negative x plus 1 over negative x times negative x plus 4. This reduces to negative x plus 1 over x squared minus 4. This is neither our original function nor the negation of our original function. Therefore, there is no symmetry. So it's neither even or odd. Say neither even or odd, or you can just say no symmetry. Okay, the next step is to reduce it in lowest terms. And r of x has already been reduced. It's already in lowest terms. We can't reduce it. If we could, we'd have a whole. And that's going to come on later. So it's already in lowest terms. So our vertical asymptotes, this is step 4, are, you look at the denominator, so that means x equals negative 4 and x equals 0. Okay, step 5 is to find the horizontal asymptote. Since the degree in the numerator is less than the degree in the denominator, then we have a horizontal asymptote at y equals 0. Okay? Now we also have to determine if the graph crosses or intersects the horizontal asymptote. So we set our original equation to this. So we have 0 equals x plus 1 over x squared plus 4x. Again, the denominator cancels. So we get x equals negative 1. And when you plug that back into the original equation, you're going to get 0, because you would get negative 1 plus 1 over something, and that's going to be 0 over something. It's just going to be 0. So our point is negative 1, comma 0. That's where it intersects the horizontal asymptote. Now step 6 is where you're supposed to put in the calculator. And what I'm going to do is just do, see, I'm going to do some line paper here. Act like I can't use a calculator. So if you want to skip this step, we're going to look at the interval. The number chosen, value of r, location of graph, and point on graph. And then we're going to graph. So let me do this. All right. So the number line here is going to go from, we're going to try negative 4. That's our asymptotes. We're going to go with negative 1. And we're going to go with 0. Okay. We're using negative 4 and negative 4 and 0 because that's our vertical asymptotes. We're using the negative 1 because that is where it crosses the graph. We got to figure out what's going on. So basically, the interval we're going to use are negative, let's do this in red, negative infinity to negative 4. We're going to test negative 4 to negative 1. We're going to test negative 1 to 0. That's where it crosses. And then we're going to test 0 to infinity. Now the point number I'm going to choose in here is just -5. I'll choose -2 for this one. In between here I'll choose -1/2. And I'll just choose 1. Just get as close as you can to what you can do. So what we're doing is we're going to plug in at -5 to find our y, which is going to be -4/5. The negative means that's below the x-axis, and the point on the graph therefore would be -5, -4/5. Okay, on this one I'm going to test r -2. This equals 1/4. This is above the x-axis, and our point would be -2, 1/4. On this one, we're going to test r of -1/2. That gives me -2/7. You're going to have to plug it in. I already did that. This is below the x-axis because our point is -1/2, -2/7. And the last we have, I'm going to test r of 1. Let's do that in, let's see. Just here, r of 1. You plug in 1, you get 2/5. And this means it's above the x-axis. Therefore, our point would be 1, 2/5. Okay? And we're going to go ahead and graph this. We have asymptote at x equals -4. So put that here. I can't draw very well on this, but so here we go. This is x equals -4. And we also have an asymptote at x equals 0, which is right here. Right on the axis here. X equals 0. Alright, and I'm going to put my points in. I know I have a x-intercept at -1, 0, and it crosses. You recall we also have a horizontal asymptote at y equals 0. So in this interval from -4 to 0, the point I tested was -2 and 1/4. So I go to -2 and 1/4. I'll put it about here. All right. And so this part right here goes like this. It does cross the horizontal asymptote. Now from -infinity to -4, I tested -5, and that went to -4/5. And this part doesn't cross, so we have our framework here. Looks kind of like that. This point was -5, -4/5. And then from 0 to infinity, I have 1, 2/5, so about here. It doesn't cross. The graph never crosses the vertical, you guys. It can cross the horizontal or the oblique. So this point was 1, 2/5. And we had our 2 points here. This one was where it crosses, which is also the x-intercept, which is -1, 0. And this point here, right here, was -2 and 1/4. Okay, that's all. I'm going to do several of these, but this is the first one. I'll go a little faster on the other ones. Thank you and have a nice day. Bye-bye.